ends of them always are just so dumb because they're either in the class or just like looking at it, or it feels like it's just oh, the one that's later.
All right, here we go. Would you please, this first one is just a classic AP problem that I did not get into the problem set, but give it a look. See what you think there. It's not in the homework number 80, just tell me what you would answer. Actually, let's go through. Now that you read the given stuff, what do you think about A? Yes or no? Is it true or could it be false? Why must it be true? Why must A be true? IVT. The conditions for IVT are met and 0 is between -5 and 4. So that has to be true. What about B? Think about B.
MVT only guarantees D.
MVT says, is there an instantaneous rate of change equal to average rate of change? So to get into that, you need the average rate of change. What is the average rate of change on the interval? 3. So is B guaranteed? No. When I see that derivative, I think, must there be a place where the derivative is anything? I think MVT, by the way. It looks like D is guaranteed by MVT, but not B, so B is looking good. What about C? Must there be a place where Y, F is Y, where Y is 3?
Yes.
Yeah, at -5 to 4, it's got to pass through 3, so that's a yes. What about the last one? What's that a reference to, or what theorem is that we're talking? Not Rayleigh. Must there be a place such that f at c is greater than or equal to f of x for all x? That means there is a y value, a specific y value, greater than or equal to all others, so there is an absolute max. That's the EVT. Is there a guaranteed absolute max?
Yes.
What has to be there for a guaranteed absolute max? Continuous on and closed interval. Is it a closed interval? And it is continuous, so it must have a max. So that has to be true. The only one that doesn't have to be true is B. Could it be true that the derivative is 0 in somewhere? It could be true. I just don't know. All right. Let's go on to number 7 on the homework for a warm-up. Then we'll get to the notes. Number 7 on the homework. Go to box 7 on the homework. It says f of x is x cubed minus x on -1 to 1. Show that the 3 conditions for Rayleigh's theorem are met. Now, MVT has 2 conditions. What are they? F is continuous on closed interval. Is it continuous on the closed interval? Yeah, Q function is continuous on a closed interval. What is the other condition? It's differentiable on the open interval. I just find the derivative in the interior, so I use the derivative to exist on the interior. And is that cube differentiable on the interval? It is, so that's cool. What's the third condition of Rayleigh specifically?
-1.
Yeah, f at 1 and f at -1 have to be equal. What is f at 1? 0. What's f at -1? 0. Now that's saying that the average rate of change over the interval is 0, which by Rayleigh then says there's got to be a place where the instantaneous rate of change is 0. All right, so those are the 3 conditions for Rayleigh. They all have been met. This function meets the bill, fits the bill. So now we can go on to the Rayleigh idea, which says, or the MVT idea, says there's some C where the derivative, or the instantaneous rate of change, is the same as the average rate of change, which in this case is, instead of A to B, -1 to 1. Now I guess I could write that, but I know the top, if it's a Rayleigh case, should be 0, because the average rate of change should be 0. The y values are the same, which they are. So I really need to just find where there's the derivative 0. Well, what's the derivative?
3x squared minus 1.
3x squared, I'll go with 3c squared minus 1 needs to equal 0. And so c squared needs to equal 1/3. So c is Plus or minus the square root of 1/3. Both good candidates, both in the interval? Yeah, they're both in the interval, right? So, that's it. You with me? Is this going okay right there, Rhoda? Okay. Would you take a look at 12 then? 12 pooped me out. Seems like it was out of nowhere. But then I got into it and it started to make sense. It said find f prime over f. Okay, weird, whatever. But f is x sine cosine of x. Now, could I take the derivative and then just stick it over the function? I could. And you guys are probably good enough that you could do a 3-part product rule without error. But I don't, getting into it, I think they had another intention. This is pretty ugly, right? What can you do when you have a big ugly product? Yeah, log differentiation. Remember back on set 84, you could take the log of both sides. What does that allow, or what does that do for you? It allows you to split it into a sum rather than a big product. Log of x plus log of sine of x plus log of cosine of x. Still not sure what the heck that stuff is all about, but next up you'll see. What's the derivative of the left? 1 over f of x times f prime of x. Hey, that's what they wanted me to find. I normally would move that f of x over, but in this case I'm just going to leave it there, yeah? So I'll just leave it there and I'll be done. What's the derivative of the right side? What's the derivative of the next term? Cotangent of x. What's the derivative of the next term?
Minus tangent.
Minus tangent or minus minus tangent. Yeah, minus tangent of x. Sweet. Okay, that's good enough. Now, this lesson is it went only moderately well. Actually, I'll be honest, it went really bad. We threw the last class. I'll be anxious to see if it was me or them. We'll see. We'll see. We'll see. To demonstrate a function is even, how would you do it? How do you do it in a this is going to be actual mixture of pre-calculus, differential calculus, and integral calculus. So I didn't know what color to make. Let's show f of negative x is equal to f of x. And on an even function's graph has y-axis symmetry. About the y-axis. Okay. Give me some examples of even functions. Cosine. X squared. All right. What about 2?
Yep.
Yeah, that's x to the 0. Okay. What about an odd function? How do you prove an odd function is odd?
F of negative x is equal to negative f of x.
Okay. These seem to have been going well so far, so that's not the part I'm going to focus on. Symmetry in odd is through the origin. Okay. Question. We had a little debate about. Must an odd function then go through the origin? Give me an example one that is not. 1 over x. Yeah, 1 over x. Okay? Or a piecewise function. If it's continuous, then maybe. All right. Would you give this a little thought? Try and sketch this function. This is a test from CU test. Actually, it was a pretty good one. I liked it. You can keep it moderate. Talk it over with your math amigos if you get stuck, or if you want to check your experience now. Sure. CU makes it delightfully close to theirs. Mine's not so much. Mine's is rough. And they used to have theirs up at 50%. You know what's really cool is MIT. Their open course are awesome. You can just take classes at MIT, and they have their lessons, they have homework, they have all their tests. It's sweet. Okay. So I put the point down in the asymptote, then I went to the stuff. What's going on from 0 to 1? Tell me two things about the graph from 0 to 1.
Increasing faster.
Increasing concave up. What about after 1?
Decreasing.
Decreasing concave up. So do you have something like that? Okay. The graph goes flat. Does that also satisfy that derivative doesn't exist at 1? The graph goes flat at 0, so we're cool. Then what? No negative side?
At -1, it's x equals -1, y equals -2.
Okay, so we're going to have, at a negative x, we'll have the opposite y, so it's going to do that. And what about asymptote? It'll be a y equal -1. And then something like this. All right. Is that what yours look like? All right. Would you then consider this, and while we're in the doodling state of mind, sketch an even function for me, will you? Like, whoopity-doo. Oops, that's not quite symmetric, but you understand. Darn it, why did I try to overachieve? Ah, no. Why did I, yeah. Apart. Okay, so, whoopity-doo. Okay, so say you sketched a slope at any old x here. Now, sketch the slope at the mirror image of that x. What do you think about those slopes? Surely not the same.
Change signs.
Change signs, opposite, reciprocal, or just change signs? Just change signs. Okay, so it seems like our theory is that the derivative at negative x, when I went to go to the derivative at negative x, what? It's the opposite of the slope at positive x, which is to say the opposite. Now, what would that imply?
Derivative of an even function is an odd function.
Yeah, that's odd. I mean, that's the definition of odd. And so it seems like is the derivative of even odd. Now, I could get a lot of things that seem to verify that, like what's the derivative of x squared?
X.
X. That's even and odd. What about the derivative of cosine? Negative sign, and that's odd. Okay? That's great, but that's not proof. That's two examples that seem to work out. That's not proof generally. So let's prove it. Prove the derivative of an even function is an odd function. When you prove anything about derivatives, you almost always work from definition. Now, the first definition of the derivative is pretty disastrous. That's alternate definition, similarly difficult. The best one to go is the symmetric definition. We're going to prove that if f of x is even, that f prime is odd, which is to say I need to prove that the derivative at negative x is equal to the opposite of the derivative at positive x. That's the definition of an odd function. Even if it's a derivative function, it's still a function. So I need to prove that, yeah? Let's start with f prime at negative x. By definition of the derivative, symmetric. Okay, now normal symmetric definition is f of x plus h. What am I putting in for x? Negative x. Okay, so f of negative x plus h minus, and then the next part is usually x minus h. But in place of x, I'm putting in negative x. 2h is unaffected. 2h is 2h. All right. Okay. Great. Now what? Can I use that? I haven't really used the even thing yet. So what? What does even do for me? What about just focus on this? What does even do for that? Okay, let's deal with the negative. Wouldn't negative, let's start here. What if I have, do you agree those are the same? Okay. What's that? That's just f of x minus h. Because it's even, f of negative anything is the same as f of positive anything, right? So that will become f of x minus h. Bless you. Okay? By the same kind of token, this guy, if I take out a negative to get my even odd thing going, then if I take out a negative, it becomes the opposite of x plus h. And then f of the opposite of that, if it's even, is the same as f at that, yeah? You follow? Okay. Man, this is getting there. Is that the definition of the derivative? Or is it a little off?
Negative.
Yeah, these are switched. Isn't the derivative supposed to be those switched? Can I switch those? Yeah, if I take out a negative, I can switch those. That's the opposite of f of x plus h minus f of x minus h. Well, that's like a negative 1 there. What if I have a constant and a limit? What can I do? I can pull that out front, negative 1 times limit as h goes to 0 of f of x plus h minus f of x minus h all over 2h. Well, that inside there, that looks familiar. That is the derivative of plain old f, or normal derivative. So, when we started with the derivative at negative x, through a lot of the use of the even function, we can eventually get to the fact that it's the opposite of the derivative at normal. Oops, this should be the derivative, yeah? All right. This one will cause you to think a little bit, if I'm not mistaken. Feel free to talk it over with your math amigos, and let me know if I can help you. We'll go over it in about 5 minutes. This is one of those that requires you to think at a deeper level. This is what you practice most times. Do on the AP test.
Because as you find, you can use this whole thing. Okay, so the normal line is perpendicular to the function. So if you find the slope of the normal line, the slope.
I thought the f prime and negative 3 was easier. F at negative 3, people had a much harder time.
You find, so the slope of the normal line is equal to the inverse of the slope at f 3.
Yeah, so it's not negative?
So the slope at f is 3, but the slope of f prime of 3 is inverse of the slope of the normal. So what do you since f prime is negative, it's the opposite.
Oh, and then you can find points. And then you get. Oh, wait, no, it didn't say. Oh my God.
Not necessarily.
What?
No, but it's easy.
You can't.
You can't, maybe you could. No, how can you? The whole.
You can't integrate, you don't have to.
All you have is a slope, not a function.
Elizabeth, you don't have an additional condition to integrate.
You don't know what your cost is.
It's just, there's just too much unknown to I guess I should get this done myself so I can have
One third. I went.
Oh, you made
I went everything. Because so if you put 3 into the normal line, you find f at 3, right? It's even f at -3, you have a 3.
Oh, damn it, I had that too.
Sure you did.
No, you tried to.
Yeah, the journal is
Think about it.
That's a slope factor, you don't have to worry about it.
You can find the slope. The slope is negative. F at -3 is 1/3, f prime -3 is -3.
What about you can derivative? So you get the slope.
Okay, what normal line is maybe this line perpendicular at x equals 3. So that intersects the function that it has the exact exit. F of 3 is the same value as the normal line at 3. Just, no, that's going to be a well, the graphs we have to slope.
Yeah, I think so.
Because I will give you the negative slope of the graph.
That's why it's this.
The reason to go like that.
Oh, that's right. But would you negate the normal line?
Yeah.
Because I thought about that.
Okay.
Because I see it like this, like this line like this one on the
Normal line
left.
to even function.
Would you negate the normal line then? Would it just be the same y value but negate? Oh no, it wouldn't be, no, it just would be the same y value.
So why do you think that works?
You have to say like, oh.
Yeah.
The derivative touches the graph at x
Yeah,
equals
it'd be the
3.
exact same
Okay, so you
line.
have function, right?
I think they would just be happy.
This is the normal line.
Yeah, James, you're right. So it's 2 times 3,
The line is
3y is equal to 7. 3y so f.
You have to take the normal line.
No, it's good. Okay, which did you find easier, F prime or F?
Derivative.
F prime, okay. What was your thought process? Somebody that got F prime, tell me what your thought process.
So it's a normal line, which means if you find the slope of the normal line, you're finding the inverse slope of the slope of the function at 3.
Okay, so would you agree that the slope of the normal at positive 3 is negative 2/3? Yeah? All right. So what is the slope of the tangent at 3? Positive 3/2. Okay, now that's great. That's the slope, and therefore the derivative at positive 3/2. So great, I want the derivative at negative. So how do I make that jump?
The derivative is an odd function, so it's negative.
Yeah, so because the derivative is odd, the f prime is odd, f prime at negative 3 will be the opposite, so negative 3/2. Did you get it? Okay, cool. This one is a piece that people always forget. Okay, so f at negative 3, where did you start? What does it relate to? It relates to f of 3. In what way does it relate to f of 3? It's equal to f of 3 because f is even, yeah? Okay, great. How do I find f?
If the normal line intersects at
Yeah, okay, remember that, yeah, I don't know what f is, but I do know that the tangent line and the normal line are at the curve at the same point. They share that point, right? The tangent at 3, yeah, the curve is there, but so is the tangent and the normal line. So 3 on F is the same, x equals 3 on F is the same as x equals 3 on the normal line. So I just need to plug 3 into the normal line. 2 times 3 plus 3y equals 7, so y is 1/3. Okay, they all share that point of tangents. The normal line, the tangent line, and the curve that share that point. So once you have one, then you can get y's for all the others. Are you cool? Well, normal lines are physics. Yes.
Why can't you plug it into the derivative?
Plug what into
Plug
the derivative?
3 into the derivative. It comes out with a different answer.
What's the derivative? I don't have the derivative.
Well, you can get the tangent line. Rather. You can find the tangent line just for normal
Oh,
line, and then if you plug 3 in, then you get a different answer,
so you found the tangent line at x equals 3.
which is just like negate flip, right?
Yeah, so you know that the slope of the tangent is negate and flip, so 3 halves, right? But you need a point of tangency still. Besides 3, you need. So, how did you finish the tangent line? I don't feel like I have enough right now to write the tangent line equation. I know the normal, obviously, but I don't have the tangent.
Wouldn't that be 3 1/3 as well?
Yeah, so I mean, to finish that, to get the tangent line, I need to find what this is, and to do that, I plug 3 into the normal line. Well, that would pretty much be done with the question. So, I'm not sure what here. Flip it over to the back, and this is not the back. Okay, this is a whole lot of integrals. Let's get through these integral properties really fast. The integral from A to A is 0. If you take the integral from A to B and then switch it from B to A, it is negative. Okay? What if you have a constant in a function? What can you do? Pull it out front. Okay. What if you have the sum of two functions? If you integrate a sum, it's the same as integrating the sum of the parts, the sum of the integrals. The integral of the sum is the same as the sum of the integrals. Really? Okay, is that true for products? No, 100 times no. Okay, what about additivity? If you go from A to B, then B to C, that's the same as the single integral from A to C. That's additivity. If F is even, then negative B to B is
2 times the integral from 0 to B.
2 times the integral from 0 to B because of the even symmetry. It's the same on the right and the left. So you can just take the right side and double it to get both. What about odd? Negative B to 0. Origin symmetry means you have some area below that is negative versus some area above that's positive. They'll knock each other out. These are not so intuitive, but they're in a good college text. If f is greater than 0 in an interval, then what do you know about the integral? It also must be positive. If all the y values are positive, then the integral must be positive. What about if one curve, it helps me to have a picture. If one curve is always above the other, for all values, then the area under f must be greater than the area under G. Okay? All right, and then the ones that definitely require a picture for my part. All right, so imagine there's some function here, and it looks like, who knows, it looks like this, f, okay? It's bounded below by some number L. Some constant L. And it's bounded above by some constant U. What do you know? Oh, yes, I'm sorry.
I have a question.
Sure.
Integral, isn't that just the area?
It could be signed area. It's signed area. The integrals are not necessarily positive or negative. They can, if I call it, how many people or something, it's a word problem, then it can be positive. Or if I say, give me the area, but integrals can be negative.
Okay, so like I just was confused by your like the F and G one because like I could have F where like I don't know, let's say like it's 1 or something like that, like it's just a straight line, it's 1,
Uh-huh.
and then G is like negative, I don't know, something really big below, so there's a lot of area between it and
Oh.
the x-axis.
Yeah, no, this F is still going to be much bigger than G because all these values are
Are negative.
negative.
Oh, I
So the
thought, like-
integral comes out negative.
I was confused because I thought that it was area and area could be negative.
Yeah, integrals can be negative. If I say find the area contained by the curve, then it's geometric area. But if it's just here, what's this integral? Integrals. Okay. So that would go to the wording of the question. But integrals without any other description can be negative. Velocity, we want that to happen sometime. So let's go here. If this is the case, then tell me, what must the area under F be greater than? Let me help you out here. I'm going to write this too. Greater than? It would have to be greater than that area. What's that area? What's the base? No integral. B minus A, the base times the height, which is L. Okay? Upper bound. It would have to be, the area under F would be less than that area, which implies it would be less than B minus A for the base of that rectangle times U. Okay. Upper and lower bound. Now, that said, these are humdingers. You'll need this for part C. Okay. Shall I do the first one and we'll talk about it?
No.
What do you mean no?
No, I got it.
Yeah, please do try it. I think you'll find that, well, most of these on the AP test are easy. These, I really scrounged for some humdingers. These are good ones. They're challenging. Ready for it? Okay. So do you say it's 6?
Yes.
We're wrong. Not
Negative
6.
14.
It is negative 6. Negative 6. Okay, so if you said this, oh, it's even, so this, then would you please write a big fat? No, that's not true. Okay? Yeah, what you mean is negative 8 to negative 5, going lesser to greater, is the same as the area going from 5 to 8 on the right. That's true. That's true. Now, you can only do this switching if you negate. So there, if I go to figure out what this is, then I would have to switch it. I always make it lesser to greater, which means this is the opposite of 5 to 8. This you could probably do without this step, but I'll show it anyway. Isn't that the same as 1 to 8 minus 5 to 8? No, 1 to 5, rather, sorry. So that makes it the opposite of 10 minus 4. So it is negative 6. Negative 6. Okay, try the next one. Try the next. Yeah.
Why are they both negative? Like, you ever get
Yep.
It's like different. Oh, got it.
Equal to that, so I don't.
Wait, so
The area.
I got 10 minutes.
yeah,
So,
I'm interested in this one.
so, this, I know what this.
Yeah, I thought about this.
Wait, why is it?
I agree.
No, like, sometimes I feel like we're going for your perfection, like, or the
I agree with you.
Listos? Ready? What'd you do first? The first step is crucial. Separate it. Yeah, separate it. Call it -8 minus 1 f of x. I play a little fast and loose with the arguments and the differentials. I just usually write f here. And -8 to -1 for 2, yeah? Cool. What's -8 to -1? The same as 1 to 8. And 1 to 8 is 10, so that's 10. That's cool. That's done. What about the other part? Yeah, you have to integrate it. It's 2x, -8 to -1, so something like -2 minus -16. 10 plus 14. Did you get? 24. Yes.
I thought of just like S2, I thought of it just as 2 above, like in a straight line, like y equals 2, and then taking the area under that from 1 to 8.
Oh, so you basically just took the area under 1 to 8 and added a rectangle. That's smart. You see where he's coming from? Shifting it up to, imagine f of x. First of all, let's go this side. F of x from -8 to -1 is like f of x from 1 to 8, yeah? If you then add 2, then it's like this area shifted up 2. Oh, shucks. Darn it, I thought I had a great idea there. But it's that area shifted up 2, so now you have this rectangle underneath it of a 2 by 7. So on top of that 14 area. That's nice. I like that. That's smart. Okay. As long as you... What the... All right. Try the last one if you haven't already done it. And we'll go over that in a minute. Yes?
Because it's even, because it's even, regions on the left will mirror the regions on the right. So photograph photograph, not the plus 2, but maybe this one, it will look exactly like, going next to right. So I basically thought about the.
Oh, you want to go to the left first? Are you ready? What are you thinking here? When you see product, you think, I think either use of or integration by parts. Which is better here? The latter, integration by parts, because one's not the derivative of the other. There's not really a chain rule use of kind of thing going on. It's more of a totally random pairing or product. So yeah, think integration by parts. What is your u? X, what's dv? F prime of x dx. What's du? Dx, so what's v? F of x. So here we go. uv becomes x f of x, which we'll evaluate from negative 5 to 5, minus the integral from negative 5 to 5 of f of x. Okay? So this first part is cool. X f of x is 5 f at 5 minus negative 5 f at negative 5. Minus, what's the integral from negative 5 to 5 of that? 2 times the integral from 0 to 5. Yes, indeed. Okay, so what is f of 5? What is 2, did you say? 2 plus 5 times, what is f at negative 5? It's 2 because f is even, minus 2 times, and the area I forgot to give you that I just gave you is 7. So 20 minus 14 is 6. That is as ugly as you'll ever see on the AP test. You are now prepared. And then, okay. Yep. How'd I get?
Oh, wait, oh, that's,
Yes.
is that 5 0? Okay.
Yes, my handwriting's atrocious.
That's not 5 times 0, 5 times 0.
Okay, let's go over at least a wee bit of the mean value theorem. If we don't get to it all, we'll go over the rest on Monday. I didn't post this because I wanted it to be a discussion. Now, in retrospect, I kind of wish I would have, because that lesson took longer than I thought. For A, why must there be a value of, good luck, y'all. Why must there be a value of h that's negative 5? All right, f and g are differentiable, so f and g are continuous, so h is therefore continuous, yes? All right, that follows, I agree. All right, so what about, to get the intermediate value theorem going, I understand what you're saying. We kind of need the betweenness to establish the betweenness. So did you go to h of 3? And what did you get for h of 3? Negative 7. Do we all agree? Okay. Did you do h at 1? What did you get? 3. All right then. Would you agree that negative 5 is between negative 7 and 3? So the IVT applies. All right. So how did you say it? Negative 5 is between negative 7 and 3. I don't know. Somewhere in there you need to say that. How did you say it? IVT. It's just continuous. I guess I already said that. By IVT, there must be a value of r. I just basically regurgitate. There is a r. It is between 3 and 1. Wait. Such that h of r is negative 5. Now in terms of what you must say, you must have conditions met, h is continuous, and then cite the IVT. You must establish, you must find the endpoints and establish betweenness of the one they ask about. You have to at some place say the negative 5 you request is between the values I know, and then you're pretty much home. Yes?
So you don't need to use the prior or the equations given, right? Like f and g?
In other words, do you need to show h, where h of 3 is coming from? I did. I just kind of was going by what you guys said. But yeah, this, I don't know if, yeah, they would like to see that. That's just good. You should show. Yes? Okay? Yes?
Just to say that, like, would you agree that h is continuous when you say h is continuous?
If you just said h is continuous without saying why you say that, they would be okay. Okay. Are we good on it? All right then. B, the minute I see must there be, these are called, in the big picture of math world, these are called existence theorems, all right? Must there exist an H? Must there exist a R or C? Mean value theorem is an existence theorem. When I see the derivative, must there exist a derivative, you should think mean value. All right, so what did you do to start here? H is continuous, and what else needs to be met for MVT? Yeah, it is continuous on the closed. You could just say continuous and differentiable for all if you'd like, because it is differentiable for all. Or just say continuous and differentiable because it is. Then what? So by MVT, there must be a value. You must use the value they give. So if you're using C, because that's just how you always do it, you're going to lose a point. They ask you, is there, actually it is C. Sorry. Up here, if you use C or something because you're used to it, instead of R, you would lose a point for that. You have to use what they give you. So in this case, it's C. MVT, there is a C. By the way, there's that symbol for that is there exists a C. It is backwards E, if you like. There is a C such that, which usually in logic terms is that, such that what? Actually, a C in 1 to 3, right? Okay, and then such that H prime at C equals H1. Now you don't have to show those because that's in the record where those came from. H of 3 is -7. H of 1 is 3 over 2. And so, boom, -5. We showed there's an average rate of change of -5. So there's got to be an instantaneous rate of change of -5. Cool. And, yep. They did. No, they didn't. Good point. That's bad math on my part.
For the inside part, you have to though.
So actually, I gotta say, in a lot of college, the way a lot of colleges teach it, at least one of the ones I went to, they used, if you went H and then upper H, that's kind of like an antiderivative thing, and those are different. So I might use a point. I don't know about it on the AP test, but on the college, good point. Okay, what about this last guy? It screams not MVT, fundamental theorem of calculus part 2, but did you get the chain rule part in there? All right, so W prime of x is, always state the general derivative, then the numerical derivative. So what is W prime? F of g of x times g prime of x. There's a chain rule component to that. We'll finish going over this on Monday. You may keep it until Monday. Have a lovely 3-day weekend. Yeah. That's on it. Why you gotta be right so much? Thank you, Elizabeth. Yes, it should have been B, not D. Right? Domain, yeah, I did not look at the domain.
I feel like that's or at least like petty people get the best grade.
Petty people?
Yeah, if you're petty and like you're